Okay, folks, we are now talking about CNC operations, and this lesson is designed to help educate you in the creation of CNC drawings and the features that you have to be able to send your designs and details to CNC systems. One of the features that we use a lot is a plasma cutter with the CNC control, but there are many other applications beyond that. So first, let's talk about what CNC is briefly. CNC actually stands for Computer Numeric Control. And essentially what that means is the computer is taking the human aspect out of the equation. Instead of a person, drawing up a blueprint and giving it to an operator, here's the operator Joe here, to make the part, we now actually have a computer system that, for example, a plasma cutter, that just bypasses the person, other than the person turning this computer on, and reads the blueprint or reads the design itself, and then cuts, mills, or whatever is necessary based on that information. Another way of thinking about it is that a computer numeric control is all based off a grid system. Okay, so let's say that we have a grid here, and this is our point of origin. And let's say this is position 1 in the x-axis, position 2, position 3, position 4. By this time you should be familiar with x and y coordinates, as you've been seeing them fairly often in your AutoCAD form right here. Alright, so with that in mind, we have our x-axis and we have our y-axis. And essentially what goes on is, for every point or curve, for example, let's say I were to cut out a hole, and my hole was kind of like this, the computer will start at the origin and it will read the coordinates along this grid. For example, it will start making a cut at position 1, 2, which is this position right here. It's the x position, the y position in the grid system. And then it may curve around reading individual little components, and eventually it's going to be here as well, and here, where this coordinate may be, this one right here, may be considered 1.5, 1. Again, it is along the y-axis of 1, along the x-axis at roughly 1.5, and therefore that right there is the coordinate of that point and that cut. And that's essentially how it works. There are a few rules with CNC systems, and specifically the cutters that we use, that you need to be aware of. For one thing, our drawings have to be, first of all, continuous. Our drawings have to be closed loop. I'll say closed loop there. Our drawings have to be clear of excess geometry. And what that basically means is that you can't have extra objects that aren't really a part of the cut. And another component of what we have to do is that it has to be located in the vicinity of the origin. And the origin is what we consider the 0, 0 coordinate. And when I say vicinity, you'll understand what I mean here in a little while. But that means that the object that we're going to cut has to be in the relative vicinity of this point on the AutoCAD axis. And number 5, the final result has to be in DXF file format. Which that's a no-brainer. That's a real simple thing to do. It's just a simple save as procedure. So these are your basic rules of CNC operations. Your objects are continuous, they're closed loop, clear of excess geometry, located in the vicinity of the origin, and DXF file format. So let's do an example to kind of make sure you understand how this works, and I can probably help you clear it up by practical application. First off, let's say that I want to have a CNC plasma cutter cut out a smiley face. So I'm going to draw a smiley face, and let's say the smiley face is going to be a diameter of roughly 6. Okay? So I'm going to create my smiley face. And here we go. Got a little spline there for that. Maybe an ellipse or so. Well, we'll just actually draw maybe another spline for the eyes. Seems like my AutoCAD is frozen up for a second. There we go. And I'll just copy this eye over here. So there's my smiley face. And let's say I want to take a sheet of metal and I want to cut out this smiley face. Well, here's some of the reasons this smiley face won't work. For one thing, we have to establish our rules. Is the object continuous? Well, actually, let me say it this way. Knowing that the plasma cutter only sees holes. That's all it sees. It doesn't understand lines or concepts. It only sees cut points. What it cuts around from cycle to cycle. So, is it continuous? Well, the fact is that my mouth here is a single line and therefore may be continuous in the fact it's a spline, but it's not closed. For example, I can't actually go from this end all the way over to this end. There is a break here. So first of all, my mouth won't work because it's not a continuous closed system. Now my eyes are continuous and they are closed, so it'll probably work. My circle is continuous and closed, so it'll probably work. So I need to fix my mouth. So to do that, I'll change my approach to using maybe a polyline. I could still use the spline, there's nothing wrong with it, it's just the polyline will work a little bit better for my situation. And I'm going to make a little bit more of an open mouth smiley face. And you'll notice that I close my object upon itself. One thing I don't really like that smiley face. I'm going to do that again. Let's go a little bit simpler. Now when I get near the end, I can either snap to that point or I can hit C and enter on my keyboard and make it close itself. Now when I click on the polyline, you'll notice that the entire thing selects, which means it is continuous, and you can tell it's closed. So I have a continuous closed, continuous closed, continuous closed, continuous closed. Let's say I decide to add a tooth back in after the fact. Well, that's not a big deal. I'll just go ahead and add a funky little tooth here, and there we go. Use my trim commands, which you should have learned those by this point, and I'll trim it out. Now, I've got another problem. Now it's closed still, but it's not continuous. Notice how these intersections do not highlight. So I'm going to have to address that in a second. Also, let's say I want to add some hair to my smiley face. So I'm going to just add a few little spikes of hair here. And I'll also use my trim command again to kind of trim out the excess here, 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 here. Actually, that last one wasn't the ideal spot. Let me do that again. Trim out these. And I'll get rid of this, 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 and this. Okay, so now my smiley face has got kind of a punk rock look to him, and we have all kinds of things to think about. For one thing, we do have closed. All these are closed, but nothing is continuous other than the eyes at this point. So the question is, well, what do I do about this? How do I make this a continuous closed system? Especially knowing that, again, the plasma cutter only sees holes. So to address this situation, there's a command you may have already learned by now, and if you haven't, I'm about to tell it to you. It's called the boundary command. It is activated by simply typing in the letters, use the right command here, B, O, and then hitting enter on your keyboard. That's the boundary command. Boundary command works like this. It's a pretty interesting little command. Type in BO and hit enter. A little window pops up and it allows you to select your object type. You want to select a polyline because a polyline is a continuous system. So I hit polyline and then I click on pick points. I will then pick inside my smiley face. Notice that I'm not clicking on the line or up in this area. I'm right in here. I click. The whole thing highlights. I hit enter. And it tells me that there's something wrong with the polyline itself. It's probably some of my creation. Well, let me see what I can fix real quick. Yep, it was in fact my eyes. Sometimes it really doesn't like splines. That's one of the reasons that I use them very often. So I'm going to go back and I'm going to make my eyeballs out of ellipses. And maybe a little bit wider. That should probably work. Okay. There's my smiley face again with the elliptical eyes instead of the spline eyes. I type in BO and hit enter. And make sure it's select polyline, hit pick points, click inside the smiley face. Typically I do like to make sure that my object in question is within the screen, not like this. Sometimes it gives the boundary command fits when it's outside its visual image. So anyway, I just click inside here, the whole thing selects, I hit enter, still giving me problems. Well, let me try this again. Alright, it didn't even like the ellipses on that, so let me try something else. I'll just make it with a regular polyline button, and I'll just kind of zoom in and kind of make it smooth. I could be using a regular line command too, this will work as well. And a lot of times you do have to do this. A lot of times you run into little problems like this where you'll just have to trace over with regular lines what you want. With enough clicks you can make it as smooth as you like. Alright, one more time. Boundary command, BO, and hit enter. Polyline, pick points, click in here, enter. No warning sign this time, everything worked out. Did you notice how when I did the boundary command, I'll do it again, that the whole thing selects, and when I hit enter, nothing really changes? Well, here's the trick to it. The boundary command takes whatever you draw and then just basically traces an outline around each component. So for example, when I click once here, click once here, click here, click here, and use my move command, just my good old-fashioned move, to move it from here to here, you're seeing the original geometry. In fact, there's probably several of them because I did the boundary command so many times. Right now I'm actually hitting delete and deleting away the original geometry. This is what I mean by saying that you can't have excess geometry. Basically, the CNC reads everything that's presented to it. So if you go in and have a bunch of stuff underneath your original creation, it'll freak out. So we have to make sure we don't do that. That's why you saw me, and I'll back or undo back. That's why you saw me click on one component at a time, not doing a box selection, but one component at a time, and doing a move command and moving it off. Then I can go back and delete all the original geometry that was built in with it. And you can see that every time I did that boundary command, it created a new component. So I'll delete it all there. So now I have a single eye, a single outline of a head, and a single outline of a mouth for my operation. Now you notice I freehanded all these creations, but that's not a big deal. You can actually have real full-fledged dimensions too, which typically you do with CNC systems. Another thing that I can do is I can trace text. Watch this. I'm going to do an mtext command, and I'll just create some piece of text here. Hopefully it's going to load up in a second. There we go. I'll just type my name. Now my name, I'm going to switch it to some kind of interesting, or at least some kind of font to use. The problem with this font is that that's going to be too big. The problem with this font is that the CNC will not be able to work with this, but what the CNC can do is allow me to turn my snaps off and trace around the text in question, which is typically what we do. As long as we trace around the piece of text, get it to the right height and everything. I probably should have taken a simpler font type. And make sure we close around every letter. See how I created the E around that? And let's do the R real quick and we'll stop there. Kind of do have to pay attention to where you start with this stuff. There we go. And when you get around curves, you start snapping, or you start clicking a bunch of times to make it a little bit more smooth. And I'll close it there. I also need to come back and polyline around this. And then I can click, and use my move command to move it up in place too. Now I won't go through the process of creating all those. We'll just start with that right there and say we're going to add that to our, whoops, missed something. We'll add that to our overall cut. Couple things to note though with CNCs, that you are limited on how close you can get. For example, this E and these R are a little bit too small. So I'll use my scale option to scale them up 1.5 times and maybe move them away from each other a little bit so that the CNC will be able to make these cuts without flaring out. Some things you got to watch for, and actually this is a little bit still too small. but that's also dependent on your machine too in terms of its precision. So I'll maybe just get rid of this, and I'll just scale up the E so that's a little bit bigger. There we go. Okay. Alright, now we're going to stop for a second too, because the video is getting a little bit big. So pick us up here in a second.